The GPM mission is a sophisticated network of satellites, covering the entire globe in less than 3 hours, giving us an unprecedented picture of precipitation from rain to falling snow, hurricanes and monsoons, droughts and floods. So how do we get all of that information out of this? The short answer? Tons of data from all over. As GPM takes snapshots of precipitation, like in a major storm, the data gathered is transmitted to a network of satellites called TDRS.
The important thing to recognize is that the GPM satellite doesn't talk directly to the Earth, it talks to the communications satellite, which is known as TDRS. And TDRS satellites talk to a ground station which is at White Sands, New Mexico. And that's a very effective way to get continuous data which cannot be gotten otherwise unless you do direct broadcasts and have many, many ground stations, which isn't as effective as going through the TDRS system.
The White Sands ground station then sends information about the health and geolocation of the GPM core satellite to the hub of all of this activity, the Missions Operations Center, located at NASA's Goddard Space Flight Center. The raw data streams into Goddard's Precipitation Processing System, or PPS. The data from the radar is routed through GPM's partner, the Japan Aerospace Exploration Agency, for initial processing, and then is sent back to the PPS.
The data that come down from the satellite are actually not precipitation. They're in the form of radiances in the case of the microwave instruments, or reflectivities in the case of the radar. The computer codes I've been talking about, the algorithms, are the way we get from numbers that nobody, including me, can directly interpret to the thing that we care about, which is precipitation.
The GPM mission is not just the core spacecraft, but also a constellation of existing satellites from partners around the world. Each constellation member may have its own unique scientific objectives, but they all contribute data to the PPS in order to develop global precipitation products.
Precipitation Processing System gets data from the satellite and various other sources and creates the science products that are going to be used for both applications purposes, that is societal benefits, and scientific research.
The PPS then produces a suite of data products, including both instrument-specific and merged data, unifying the data gathered by the international partner satellites that make up the GPM constellation.
You could compare this to making soup. We have carrots, and we have onions, and we have potatoes. They're all vegetables, and so you have to wash them, peel them, take out the bad spots. That's a really important step. You don't want your soup to taste bad. When you get done, of course, you have to taste test it to make sure you have the seasoning right, and then you have to serve it. And so each of those steps, in a mathematical sense, is what we have to do in order to take all the diverse sources of information and end up with a unified product which the user finds to be useful.
These precipitation products will be useful in many societal applications, like hydrologic modeling, mapping potential natural disasters, agricultural monitoring, weather prediction, and climate research.
As we improve the precipitation retrievals that form the basis for these merged products, that will get better and better, and we'll be seeing actual satellite data rather than just forecasts.